now that we've reviewed the basics of graphing inequalities, it's now time to remind ourselves how to solve inequalities. So we're going to start with fairly easy stuff. This is section 2.4. The I can statement is I can understand and solve one-step inequalities. One-step inequalities. Okay, so we're going to remind ourselves how to solve an equation. We're going to use the same type of skills here. So in the warm-up, this is what we're going to do. We're going to solve the equation, then we're going to graph the solution on the number line. So here's the variable term. We're going to isolate that first. So we're going to get rid of the 4 by adding 4. So we get 3 halves x on this side, and then over on this side, let's see, we've got -1 plus 4. That's going to be a positive 3. Remember, they're different signs, so we're going to find the difference. We've got a fraction in front of the variable, so we're going to multiply by the reciprocal. The reciprocal of 3 halves is 2/3. So we're going to multiply both sides by 2/3. And remember, we've mentioned that if there's a fraction in the problem, you might as well think of everything else as a fraction. So I'm going to put that 3 over 1. And notice what happens here. The 3's cancel on this side and the 2's cancel on this side, which is exactly what we want. We've got the x by itself over here. And then we can do some cross cancellation right here before we multiply. Please don't go ahead and multiply these and get 6 and multiply those and get 3 and then take care of it from there. You can do that, but it's kind of a bad habit. Get in the habit of cross canceling. So we're going to cancel the 3 with a 3. So that means we have a 2 on the top, a 1 on the bottom, which is just a plain old number 2. It's just that nice integer of 2. So if we were to graph this answer, it's not a very interesting graph. Again, we're always going to put 0 on here, and then I'm going to put 2 right there, and we're going to put a big dot right there, fill it in, and we're going to put a 2 right there. Well, that's how we'd graph the solution to an equation. It's just one single dot. Okay, but now we're going to remind ourselves how we can solve inequalities. But the first thing we want to remind ourselves is what those inequalities look like. Now, I'm going to read these from left to right. So this is a less than. The next one is the same thing, but it has that little equal to bar on the bottom of it. So this is a less than or equal to. So less than or equal. This one has kind of the bigger mouth on this side. So again, reading from left to right, this is a greater than. And then this one has the equal on it, so this one is a greater than or equal. Okay? So greater or equal here, greater here, less than or equal, and then less than right here. So we're going to throw these symbols in these little expressions right here. And let's see, 3 and 5, so that's going to be a less than. Oops. And I struggle with drawing these sometimes, so bear with me here. 10 and -6. One thing some people do, and I run into this a lot, they kind of make it look like a 7, so don't do that. 10 is bigger, so we definitely want to make that big mouth over here and the small point toward the small one. Same thing here, 8 is greater than 2, and -8 and -2. -8 is further to the left on the number line, so this would be a less than. Now, what I want to point out, I mentioned this last time, but you can read these forwards and backward. So if we read this as 3 is less than 5, 10 is greater than -6, and so forth, that's totally fine. You can think of it that way, but it should make sense if we read it the other way. In fact, you should be really good at reading both directions. So this is -2 is greater than, that's the greater than side, is greater than -8. This is 2 is less than 8. This is -6 is less than 10. See, that still makes sense. -6 is definitely less than 10. And 5 is greater than, see the bigger than side here, greater than 3. So whether you read it from left to right or right to left, it should make sense either way. Now, unlike when we solve equations where we get one answer, when we solve inequalities, we get a range of answers. We get a whole bunch of answers. That's why when we shade in the solutions on a number line, we get a big shaded area. Well, the good news is, and you might remember this from 7th grade or whenever you learned this, we solve inequalities just like we solve equations, except when we do a couple of things. Except when we multiply or divide by a negative. If the step we're taking to solve the inequalities is we have to multiply or divide by a negative, then we switch the direction of the inequality. We switch the direction of the inequality. And there's a good reason for that. When we multiply or divide by a negative, what we're doing is we're introducing a negative, and that means opposite. So that's going to change things to the opposite direction. So again, just as a quick review, if we were to graph this inequality right here on this number line, I'm going to put 0 right here. 6 is the most important number on the number line, so I'm going to circle that. I'm not going to close it in, but I'm going to read this from the variable. I'm going to do x is less than 6. So that's the left side over here, so we're going to shade it like this. On this one right here, again, it's already solved, so we've got negative 4.5 on here. So I'm going to put a 0 here. I'm going to put a circle down here and label it as negative 4.25. And then read this from the variable. So this is going to be y is greater than or equal to negative 4.5. So the y's, the answers are bigger, so we're going to shade this direction right here. And then we've got 11/3. Let's see, if we're going to graph that the right way, we might want to think of this goes in here 3 times with 2 left over, so that's going to be 3 2/3. So that's going to be on the positive side. So we're going to write down a circle right here. We're going to write 11/3. It's in between 3 and 4, pretty close to 4 actually. I missed this. This is equal to, so we've got to close that in. Sorry about that, forgot that. And then on this one right here, we're going to have to do the same thing. Always a good idea. I broke my own habit. You always draw that circle and then figure out whether you're going to close it in or leave it open. And then let's read from the variable. So this is z is greater than or equal to. So greater than, that's going to be on this side. Now, you may have had somebody that told you can just shade the direction that the arrow points or the inequality points. That's only true if it's set up with the variable on the left-hand side. It doesn't work on something like this. So please just read from the variable and you'll be in much better shape in the long run. That's a shortcut that does not work many times, so please don't do that. And again, just as a reminder, as I've been talking about, it's usually best to read an inequality from the variable. So I've got an example right here. Both of these are exactly the same. So if I read this one from the variable, x is less than 2, I could read this one, 2 is greater than x, but if I read it backwards, it's read the same way. X is less than, that's on the small side of the point right here. X is less than 2, they're read the same way. So if you'll practice that, you'll be in really good shape. All right, let's take a look at example 2 and let's solve these. Again, we solve these exactly like we solve an equation, except when we multiply or divide by a negative, then we're going to switch the direction. So as we go through here, I want you to ask yourselves, the step we're going to take here is we're going to add 10 to both sides. Does adding 10 change the direction of the inequality? It doesn't. So we're going to leave that inequality the same direction. Whoops. So this is a less than or equal to, and we get a 16 right here. We're going to circle that. Now that's the answer to the inequality. We've solved it, but we also want to graph the solution. So I'm going to put a 0 right here. I'm going to put a 16 right here. I'm going to follow my rule there. I'm going to figure out whether or not I leave it open or close it in. We're going to close this in, and then again we're going to read from the variable. X is, on the small side, x is less than 16. So we're going to shade this direction right here. All right. Next one. We're going to get the r by itself, so we're going to subtract 5. Subtracting does not change the direction of the inequality, so we get to leave it like that. So we've got an r over here, and we've got negative 6 on this side. Again, we can circle that. I'm going to put a 0 right here. I'm going to put a negative 6 right here. And again, let's figure out whether or not we need to fill it in. It does have that equal to, so we're going to fill it in. And then it says r is, on the small side, so r is less than negative 6. So again, we're going to shade this direction right here. Okay, next one. We need to get the n by itself, so we need to undo multiplying by negative 5. So we're going to divide by negative 5. Those are going to cancel. Now, when we divide by a negative, we have to switch the direction of the inequality. So the second I know I'm dividing both sides by a negative or multiplying both sides by a negative, I'm going to switch the direction around. We've got an n right here, and we've got a negative 4. So there's the solution. Let's graph that solution. I'm going to put 0 here, negative 4 here, put the circle, again, figure out whether or not you're going to close it in or leave it open. We're going to leave this open, and then read from the variable. N is, see this big mouth right here? N is the big one. N is greater than negative 4. So they're bigger than negative 4. So we're going to shade to the right. Next one, we've got a, let's see, we've got a fraction in front of the variable. So remember, to get rid of a fraction in front of the variable, we're going to multiply by the reciprocal. So the reciprocal is 5/4. So we're going to multiply both sides by 5/4. Those are going to cancel. Now again, stop and think. Did we multiply both sides by a negative? The answer to that is no, we did not. So we don't change the direction here. So I'm going to leave it this direction right here. We have an n. There are some people that say, well, wait a minute, this is a negative times a positive, so the answer is going to work out to be negative. It's true, the answer works out to be negative, but that negative was already on this side. Notice what we did to both sides. We multiplied by a positive 5/4, so we don't have to change the direction. I am going to think of this as a fraction right here, and I'm going to zoom in on this one just to get a better look at this right here. So I'm going to do a little bit of cross cancellation here. 2 goes in here twice, 2 goes in here 3 times. So this would be negative 15 over 2. So let's see, that's going to be the answer, negative 15 over 2. So I'm going to go ahead and circle that, but in order to figure out where that is on the number line, we're going to need to do something here. So 2 goes in here 7 times with 1 left over. So it's negative 7.5. That's where we are here. So I'm going to put a 0 here. I'm going to circle this and I'm going to label that with the improper fraction there, that reduced improper fraction. We're going to figure out whether we're going to close it in or leave it open. It's got the equal sign, so it could be equal to that, so we're going to close it in. And then again, we're going to read from the variable. N is on the bigger side. It's on the greater side of negative 15/2, so we're going to shade this direction right here. Okay. All right, so we got that one. Let's take a look at the next one. On this one, it's x divided by negative 4. We want to get rid of dividing by negative 4, so I'm going to multiply this side by negative 4, and I'm going to multiply that side by negative 4. So we're going to cancel the two of those, but remember, we multiplied both sides by a negative. That was the step we were taking. So I'm going to switch the direction of the inequality, and then I've got negative 4 times 2.5. That's going to end up being negative 10. I'm going to circle that, but we are going to double check here. Let's make sure we got, let's see, what have we got here? Negative 4 times 2.5. It equals negative 10, so we're in good shape right there. So we've got a 0 here, we've got negative 10 here, put the circle there. Do we close it in or leave it open? We're going to leave it open. And then again, read from the variable. The x's are greater than negative 10. So we're going to shade this direction right here. And I kind of like this type of shading. In the long run, that's going to be better off for you than just drawing a circle and a line one way or the other. So please try and shade that way. And then let's take a look at this last one right here. And then we'll do the fill in the blanks at the bottom of the page. We're going to divide both sides by 5. And again, think about the step that we're taking to solve the equation. We're dividing by positive 5. So we don't have to change the direction of the inequality. This does not go in evenly, so we're going to think of it as a fraction, and it doesn't reduce. So the answer on this one is negative 22/5 on this side right here. So that's the answer. But remember, that's going to go in 4 times, so that'd be negative 4 2/5. So we'd be about right here. So let's put a 0 on here. Let's put a circle, and again, we'll label that with the improper fraction. But it's going to be between 4 and 5. We'll just put those on there for the fun of it. And again, read from the variable. The answers, the z's, are less than, that's the small point side, they're less than the negative 22/5. Oh, and I almost broke my rule. Did you catch that? Let's figure out whether we fill it in or leave it open. That is going to be closed in because it can be equal to that. So we're going to close that in. And again, we're going to shade to the less than side. So we're going to shade to the left. Now, the last thing that I want to take a look at is just a couple of quick reminders. We've got to keep a couple things in mind. These are fairly common mistakes. So just because there's a negative in a problem does not automatically mean that you switch the direction of the inequality. Remember, it's what we're doing to solve the equation. It's only when you multiply or divide both sides by a negative. So if we multiply or divide both sides by a negative, if that's the step we're taking, then we do switch the direction of the inequality. Again, it's the steps that you are taking that can switch the direction of the inequality, not what was already there in the problem. And then the other thing I want you to keep in mind is the solution to an inequality is all the numbers that make the inequality true. So what that means is we could pick any of the ones that are shaded, included the 16 or anything less than that, plug it into the inequality, and it will make it true. If you try and pick something that's outside that shaded area, like if we plugged in a 0 into this one right here, this would be 0 plus 5. This would say 5 here, -1 here, and this would say -1 is greater than or equal to 5, and we know that that's not true. So anything in the shaded area is a solution. It makes the inequality true. Anything not in the shaded area is not a solution. It wouldn't make the inequality true. All right.